Good afternoon, folks. This is Mike coming back at you with another video on Introduction to Algebra. In the previous video, we wrapped up section 5.3. We talked about some other methods that we can use to factor some not so nice trinomials. In this video, we're going to take a look at some special rules and some special factoring techniques that we can use to factor certain types of trinomials or binomials, as you'll see. And when we say that these certain binomials or trinomials are special, I mean that there's a special formula that can be used to factor them. Now, before I get into the formulas, I will say that the first one that I want to talk on here, this is the only one that really requires the use of any special formula. The other ones that I have to offer in this video, you don't necessarily need to do anything special with. But first we'll get to the difference of two perfect squares. We've actually seen this formula before. We saw it back in chapter 4 when we talked about sort of a special case of multiplying two binomials. So if A and B are either numbers or they're variables, maybe there are exponents, maybe it has numbers and variables, or just any kind of term whatsoever, then A squared minus B squared is equal to A plus B times A minus B. What we saw back in chapter 4 was we were given something that looks like this, and we turned it into something like that. Now we're going to go the opposite way. Now we're going to start with something like this, and we're going to turn it into something like that. And the key thing here really is to just realize what things we are squaring, and then let those things be our A and our B. So here is an example of what I'm talking about. We're going to factor x squared minus 9. So if we look at our terms here, the x squared and the 9, I mean, clearly we see that x squared is just the x being squared. And then we have the 9, but 9 is a perfect square on its own. 9 is equal to 3 squared. So we are taking the difference of x squared and 3 squared. So if I let x take the place of A in this formula, and I let 3 take the place of B in this formula, then we have x squared minus 9, or x squared minus 3 squared is equal to x plus 3 times x minus 3. And as always, you have a check here that you can do. If you multiply those things, you should get x squared minus 9. That's how you know that you have it factored properly. So we'll do some more sample problems here. We're going to factor each of these things here. Here I have x squared minus 100. Well, clearly the x squared is just x squared minus 100 is a perfect square as well. 100 is 10 squared. So what we're going to do is we're going to write this as the product of two things. I have the x's and the 10s, and one is plus and one is minus. Recall that when it's the difference of two perfect squares, you're multiplying two binomials. The terms in the binomials are the same, but the signs in the middle are just different. So x plus 10 times x minus 10. So this is how we factor x squared minus 100. But not all of these are quite as nice. Not all of them are just x squared. Something like this is something you could also see. 9x squared minus 1. So this one requires a little bit more thinking. If I look at the 9x squared here, well, 9 we know is 3 squared, and x squared is obviously x squared. So 9x squared equals 3 squared times x squared. And using our properties of exponents, if we have two things that are being raised to the same power and we're multiplying them, then I can essentially pull that power out of each of my two bases. To give me 3x, and that whole thing is squared. We're used to going from this to this, but we're just going now in the opposite way. These things still are the same, so we can still say this. So the 9x squared is the quantity 3x squared. And then we have the 1. Well, 1 is 1 squared. So what this is really 3x squared minus 1 squared. So we have the difference of two perfect squares. We have our two binomials. The terms are the same, 3x and 1, 3x and 1. The signs are just different. We'll do the fourth one here. Try the third one on your own. The 16x squared and the 144. 16x squared and 144. Well, 16 is a perfect square. 16 is 4 squared, and x squared is just x squared. So again, using that same property of exponents, I can pull that power of 2 out, if you will, of these two bases, and we multiply those bases. So it's 4x, that thing, squared. 144 is a perfect square. 144 is 12 squared. So what I have here is 4x squared minus 12 squared, and thus we use our formula for the difference of two perfect squares. Two binomials, 4x and 12 are the terms in each thing here, but the signs are different. One is 4x plus 12, the other one is 4x minus 12. Now, again, a key thing, a sort of key visual clue that we can use this formula is that there's only two terms, and we are taking the difference of those two terms. That is the key thing that's really happening here. That's what tells us we can use the difference of two perfect squares formula. Now, as I said at the beginning of this video, the rest of these rules I will throw out there because they're handy to see. There are other ways to handle this, though, other ways that we have already seen and worked with that I highly recommend that you just stick with those. Or there are ones that really do not come up all that often. So we could have, say, what is referred to as a perfect square trinomial. And what we mean by that is you could have a trinomial that is equal to one binomial squared. And these are the general formulas for being able to factor perfect square trinomials. A plus b, that thing squared, is equal to a squared plus 2ab plus b squared. And a minus b squared is equal to a squared minus 2ab plus b squared. And the key is really recognizing that what you have is indeed a perfect square. I will let you read through the sample problem on your own here. I'll let you read that sort of on your own time. This is just sort of a mental thing. This is just sort of me thinking out loud, telling you what to look for. But for dealing with anything like this, dealing with any of these trinomials or anything like that, utilize, I'll even write it here, utilize the techniques from sections 5.2 and 5.3. We've already been working with those. We're more comfortable with those. Just utilize those techniques. It will still lead you to the same answer, and it's one less confusing thing. Again, I'm just showing you these formulas because they are there. So those formulas and those techniques were all used when the largest power we had on the x was 2. So x squared plus or minus some other terms. There are some other factoring formulas that are out there. These things deal with cubes. So we have x cubed minus y cubed equals this thing. And then we have x cubed plus y cubed is equal to that thing there. But what am I really concerned, at least in terms of just new stuff, what am I really concerned about you knowing? What I'm really concerned about you knowing is how to factor the difference of two perfect squares. That is the only new thing that I really want you to take away from this video and from this section. All these other formulas right here, they're out there. They're great to know. You can use these once you get more comfortable with factoring. You can try and challenge yourself to see how we use these things. But for now, utilize, if you're going to utilize any other factoring technique to factor a trinomial, use the techniques from 5.2 and or 5.3. So guys, that concludes section 5.4. In the next video, we are going to talk about solving quadratic equations using the zero product property. If you have any questions or comments, please be sure to reach out to me, guys. Emails, voicemails, in-person visits, whatever you have to do. Until the next video, take it easy, guys.